Hello everyone, today I'm going to share with you some of my experience in using ChemDraw. I started using ChemDraw as an undergraduate and then use it a lot more often when I was a graduate student because I need to draw a lot of structures and gave a lot of presentation. Following that, I came into teaching. So for the past 12 years in teaching, I have also been actively using the software in creating questions and in drawing the structures. So there are certain features which I thought is very crucial for you to use the software in a convenient manner, and I'm just going to share with you some tips on how you can use it efficiently. So I'm not going to guarantee that at the end of the video you will become very good in using the software, but I just thought that through sharing my experience with you, you will at least know some basic features which you can use. Okay, so this is the interface of ChemDraw. I think you need to play around with many of the features, but I'm just going to introduce you to some of the interesting features. So for example, if you go to view, you notice that there's this crosshair thing. So if you don't like it, you can remove it. But I feel that the crosshair help us to do alignments when we draw structures. So for example, if I'm going to draw a cyclohexane, let's say I'm going to draw it as a reaction scheme. Let's say for free radical substitution, reaction where I'm going to introduce bromine over here. So if I do not have the crosshair, right, let's say I remove the crosshair, then it's very difficult to align my structures because I need to consciously shift it left and right. So when I have the crosshair, it helps me to put them in the right place. So for example, I can ensure that the arrows represent maybe 2 squares, and then I can shift my structures to the right. So it gives you a better sense of spacing. So I would highly recommend you to include the crosshair in your interface so that it's easier for you to control things. And then there are many other things which I wouldn't go into details. Another interesting and useful features is to showcase the periodic table. So it's over here, periodic table. So the new version of ChemDraw have the periodic table in pretty nice format. So you have a different color. So I can just put the O here. You notice that I can just put the O here. So you can just click on let's say chlorine, and then I can just click on bromine, and then it will be replaced with chlorine. So this is a pretty useful features as well. So I'm just going to delete these two, and then you notice that as you scroll down, right, there are a few other features which you can use. For example, the arrows. So there are many arrows you can use. Includes the equilibrium arrow, and then the arrows showing resonance relationships, and then of course the curly arrows for mechanism drawing. So when we draw in the curly arrows, you can just do it quite readily like this. For the new version of ChemDraw, it can actually help you to curl the arrow more like this, up and down. So this is the newer version, and it will also help a lot if you notice that the end of the arrowhead sometimes it's not very visible because at certain angle it may look like a curly arrow. It may look like a half arrow, sorry. So what I can do is I can do a right click, and then I can choose angled arrowhead. So I'm just going to click on it, and then you notice that now it becomes an arrowhead which we will normally represent on paper. Of course this looks a bit ugly, so we need to manually shift our cursor here, and then we need to adjust it a little bit so that it looks nicer. So to make it a little bit wider, it's actually more pleasing to the eyes. We can easily increase the length as well, left and right, so it's really up to you, and then the curvature. So it's very flexible. So this is the new features we have in the newer version. And then if I move down, you will notice that you have orbitals. So the p orbitals. So take note that the p orbitals have both the phase. You can easily increase the size. But I will recommend you not to drag like that. One way you can do to make it consistent is you can just highlight it, right click, and then you go to scale, and then you can manually key in say 150%. So that helps you to do your scaling. One other thing I thought is very useful for you would be to include the charges as a plus and minus with the circle. But sometimes when you click it out, it appears a little bit big, so you might want to scale it to make it a little smaller. So normally I will scale it to say 75% or 80%. Yeah, and then of course the electron pairs as well. So I need to go and find the electron pairs. I will not recommend using this, but I will recommend using a single electron and then repeat it. Okay, let me explain to you why. So let's say I'm going to increase the scale to 200%. Okay, now you notice that for the electron pair they show here, right, the distance between the two is very huge, and it can be a little bit irritating for you to adjust. Yeah, because if you adjust one, the other one will decrease in size, and then the space between them do not decrease together. So I will not recommend using the electron pair as it is. Okay, I will recommend you using the single electrons, and all you can do is just to place control, and then you just drag another electrons out, and then another circle out, and then you can just adjust it accordingly. So let's say I have say water. Okay, so I'm just going to sketch water out, having a trigonal planar bench geometry, and then I'm going to shift my water molecules up. Okay, so just going to shift my water up, okay, like this. So you notice that the lone pair is now, if you think that they are too far apart, you can just drag them, make them closer. Again, if you think that they are too big, too huge, okay, you can easily adjust the size. So I right click, and then I can scale them again. So I can scale them by say 90%. So they'll become smaller, so that it's more pleasing to the eyes. I can shift left and right, okay, for the electron pairs, or I can keep them at one corner for me to use later on. Okay, and it's very useful if you have both orientation, linear and horizontal, so that you can play around with them later on as and when you need them. You'll notice that there is this red warning here. This red warning is the interpretation of the atoms. So if you require them to introduce you to a warning where you might have drawn a wrong structure, you can easily put that in. But sometimes they will auto-correct for you, which can be quite irritating. So sometimes you can just click, you can just uncheck the interprets chemically, so that it wouldn't have the warning. Yeah, so I think this is fine. Okay, yeah. Then let me think of what other features. So for example, if you look at what you have in the exam question, so something like this. This is actually from a H3 paper. Yeah, so I'm just going to zoom in a little bit. So you notice that the structures are quite nicely drawn, okay, with the benzene ring of the appropriate size. So for example, if I'm going to draw this particular structure, right, what you normally do is you will just draw a benzene ring. Maybe some of you might not know how to get the ring out. Okay, so to get the ring out, you just tap on control, and then you release the ring. Oh, sorry, you release the benzene ring like this. Okay, and then you might be drawing it in this particular manner, and then you put a NH2 here. Okay, just put the NH2 in. You notice that the benzene ring, the middle ring, the delocalized ring system, right, it's not exactly in the same standards as what you have in Cambridge papers. The reason is Cambridge papers scale this ring a little bit. So they scale it to a slightly larger size, maybe 110. So if you do that, you'll notice that your benzene ring will be in a similar size to what you have in the Cambridge paper. Yeah, so this is actually a small issue, but I think it's worth correcting whenever you draw your structures. Okay, and sometimes I do admit that if the structures is a little bit big, right, the benzene ring might take up quite a bit of space. Yeah, so it does help if you can scale your benzene ring down in terms of size. So let's say you can scale it to say 90%. I think it helps a lot, because so that it does not occupy too much space in the whole structure. Okay, then I can just scale this a little bit, so that the benzene ring does not seem overpowering. Yeah, so that is one features you can look at whenever you want to draw. Basically, drawing has a lot to do with aesthetics. So how you want to present the reaction scheme on paper. Yeah, sometimes it does take a little bit of creativity, and then for the reaction scheme to look less cluttered. Yeah, so it really depends on like how you want to adjust the structures. Yeah, so there are certain things in my own template I have already adjusted. So for example, if you look at the objects, I have already fixed certain object length and size according to the American Chemical Society standards. Of course, on my own, I have do a little bit of adjustment as well. So for example, in terms of the width, the width of the hash, all this. Okay, so I'm going to show you why that is the case. So for example, if I'm going to draw a tetrahedral carbon, okay, so okay, I'm just going to scale this a little bit to 400% so it looks a little bit bigger. Okay, so for the tetrahedral carbon, right, it will look something like this. Okay, this is the wedge and this is the hash. You'll notice that the hash, right, is not too bad, because if I'm going to scale it by say 150%, yeah, you'll notice that it is quite visible for the eyes. Yeah, the reason why I'm saying this is because, let's say, right, if you sometimes if you don't adjust the hash properly, so let's say I go to object setting, right, if I put this to be say 0.88, right, you'll notice that the distance between each of the hash line, right, is very huge. Yeah, so when you print out, it may not be very visible. So even if I enlarge this to say 150, their distance is still very huge. Yeah, so it's not very pleasing to the eyes. Yeah, so the better setting, as I mentioned, is to change the hash settings to 0.58. It looks pretty much like the one you have in Cambridge exams. Okay, so these are some of the little adjustments which you can make on your own. Of course, once I put in the H's, it will look decently nice. Okay, so you have to be a bit careful. You have to click at the right place. If not, it will appear outside. Okay, so just make sure that you click at the right place. So this will be the methane, which we are usually familiar with. Okay, I'm just going to illustrate to you the drawing of a simple mechanism, and you will then know what I'm trying to imply to you. So for example, I can draw a cyclohexane ring. Okay, so with a CC double bond. Yeah, I normally like to just create a double bond by just simply clicking on the double bond here. Some people would like to create a double bond by just putting this like this. Go to the double bond symbols, but I usually do not like to do that. Okay, in case you do not like your double bond to be the second pi bond to be found like inside, you can just click again and then you'll be found outside, or you can just click again as well, then you'll be found in the middle. So it's really up to you how you want to adjust this. Okay, but I think this looks a bit nicer, so I'll just leave it as it is, and then I'll draw a reaction arrow. Okay, and the usual electrophilic mechanism we have in H2, right? Say we have a HBr. Okay, so we just type in the H and the Br, right? And then you notice that we need to incorporate the delta plus, delta minus. Yeah, sometimes we may not know where to find them, so it's actually quite easy. I just need to click outside here. Okay, Arial, right? I will not be using Arial, I'll be using symbol. Okay, so I'm just going to click delta plus. So this is how delta plus can be created. And it looks a bit big, so I'm going to adjust the size to font 6. Okay, and then I'm just going to right click over, and then this will be a delta minus. You can see that if you do know some of these little tricks, you can actually draw the mechanism quite easily without spending too much time. So delta H, delta plus, delta minus. I'm just going to shift this a little bit up. Okay, and then after that, I'm going to draw in my curly arrows. So I'm going to draw it near the pi bond, and then something like this. And then of course the other arrows will be like this, pointing towards the electron rich Br. Okay, again, I'm not going to accept arrows like this, so I'm going to change it to an angle arrowhead. Okay, just going to make it looks a little nicer, and then change this to angle arrowhead as well, and then shift it. Okay, I'm going to elongate this a little bit so that it doesn't like touch this the line of the arrow, so that it looks clearer. Okay, so I'm just going to shift the position a little bit. Yeah, so there are a lot of things you can do. In fact, I do recommend you guys to zoom in to do all this adjustment, because if you try to do it at 100%, right, there are a lot of things you can't do. You notice, yeah, everything appears very small. So I think doing it at large, like 300% or 400%, actually helps a lot in adjusting a lot of things. Okay, and then after that, I think in H2 you need to write in the slow step. Usually if you put a slow step, I will change the font to 7, so make it a little bit small. Okay, and then of course I'm going to generate the carbocation. Usually when you generate the carbocation, right, you might redraw this whole thing. Yeah, so in our case here, it's simple. We can easily redraw it. Okay, over here, Yeah, but if the structures gets a bit complicated, you need not redraw it. Okay, I can show you a shortcut later. Okay, I'm just going to paste the plus over here, and then this will be the major carbocation that will be formed, which is a tertiary carbocation. Okay, one way you can do it fast is basically just highlight this and then hold on to control and then just drag the structure out. Click on the eraser and then erase the CC pi bond. Yeah, so this is an easier way of doing that. Okay, so once I've gotten this, and then after that, the bromide will be out. Yeah, so normally what people will do is they will just click on bromine from the periodic table and then click outside here. But you notice that once you do that, you have a HBr, and then what you normally do is you will just remove the H, and then after that you will come out an irritating red boundary here telling you there's a warning lah. Yeah, so normally I don't like to do this. I will simply just like to just type in Br, okay, and then although there will still be a warning, but I'll just go to do not interpret chemically. Yeah, so it will not automatically pop out a H. Okay, and remember that this is the bromide, so I will need the negative charge. Okay, I will also need the lone pairs of electrons to complete the electrophilic addition. Yeah, so once I do them, I'm just going to put it back here. Okay, and you notice the arrow is gone. Yeah, because I accidentally drag it over. Okay, so I'm just going to drag it back. Okay, so slow become fast. Okay, so this will be the fast step, which I can use, and then after that I'm going to draw in the arrow as well. Yeah, so make sure the arrows you draw them in the appropriate manner. So I'm just going to let it attack the center. You notice that you can't really adjust this well, but it's okay. You can just write it, do it somewhere like this, somewhere in the middle, and then you can always adjust the length. If not, you can always adjust the size as well, so not to worry. Okay, so this can always be adjusted, so do not be too upset over it. Okay, so again, right click, angle arrowhead, and then I'm going to shift the things. Okay, so just going to put a bromide here. Okay, so that will be the fast step, and then finally I'm just going to draw the product. So again, I'm going to do a shortcut, tap on the control, drag it over, use the eraser to remove the plus charge, and then draw in another bond and then put in the Br, and that's it. Yeah, so that's how electrophilic addition can be drawn in a relatively nice way. Okay, so of course when you paste over to Microsoft Word, you have to adjust the size accordingly, but that's another video altogether. But I think the basic drawing, this is how it can be achieved. Okay, then another thing which I thought is quite useful is say the drawing of the chair conformation, which that's why it involved the cyclohexane ring I have here. The problem with ChemDraw is that the chair they have seems to be a little bit small, because the length is actually quite similar. Yeah, but when you draw in the other bonds, right, it will appear to be you will cover up the main features. So for example, I'm going to draw in a tertiary butyl cyclohexane, right? If I'm going to draw this in, you notice that this portion looks really big and kind of ugly, and then the rest of the chair looks quite small. So if I'm going to draw in the rest of the axial H's, it looks a bit overpowering lah. So for example, I can just show you, okay, like this, and like this, right? If I draw in the rest of the H's, you notice that it just makes the whole chair looks quite ugly, in my opinion. Okay, there's another thing which you notice. When I drew the bonds here, you notice that it's covering the front, but actually it should be at the back, right? What you can do is just to erase this bond, okay, and then draw in the bonds again. So now it will appear behind. Okay, yeah, so something like this. Yeah, so you notice that now my chair seems to be not in the middle of the whole picture, because it seems to be covered by the rest of the structure, the rest of the substituents lah, because I chose to draw them in. Yeah, one thing you can do is you can first draw in a chair, okay, and then adjust the size to say 150%. Okay, so that is something which I think normally helps. Once you adjust it to 150%, I think the rest are details, because they will not seem to overpower the whole chair structures. Okay, so for example, I drew in this like this, and then I'm just going to shift the chair over. Can you see that it's no longer the rest of the the tertiary butyl group doesn't really overpower the whole structure now. Okay, even if I draw in the rest of the H's, okay, they look decent, I guess. Okay, so I'm just going to try to showcase to you. Okay, just draw the H, okay, H, okay, H and H. Of course, I need to change this as well. Okay, then so that it looks to be at the back. Okay, but you notice that this portion, these two portions looks a bit weird, right? You can easily just drag it up a bit, drag it down a bit, yeah, so that it will look decently nice lah. Yeah, so not to worry about aesthetics. You can always do minor adjustment on your own. Okay, but the problem with scaling, I have to admit, is that if you are going to incorporate a double bond in, right, it will not look very nice lah. So okay, I'll just use a simple example. This is a normal chair. If I put in a CC double bond, I think it still look decent, although it's not as nice as it should. Okay, so let's say I'm going to scale the chair to, let's say, 150%. Okay, so let's say I'm going to scale it to 150, right? And then I'm going to incorporate another double bond in. You notice that now the distance between the two seems to be scaled as well. Okay, so what I normally will do is I can just highlight this and then right click, go to object setting, and then I'm going to choose spacing percentage of length. Yeah, so I'm just going to reduce this to say 12, and then you notice that it's back to something which is visible to most of us. I can also do it for this. Okay, so I'm just going to go to object setting and maybe change to say 14. Okay, so I think it will look a bit nicer from here. Yeah, so I think when you are drawing mechanism or using ChemDraw, you just have to adjust some of the things and some of the features according to your likings. Yeah. Then the final example I'm going to use will be the drawing of the second order nucleophilic substitution, which we often teach in H2. So I'm just going to draw in the substrates in the usual manner. Okay, so this will be the substrate for second order nucleophilic substitution. Okay, I'm just going to adjust this a little bit. Okay, like this. Okay, so I have a leaving group which is a Br. Okay, and maybe I have these are H's. Okay, H. Okay, and then okay, maybe I shouldn't put a H. Maybe I should put other groups such as maybe a OH here. Okay, and this is perhaps a CH3 . So you notice that now the size of this the font size looks a bit big. Yeah, you can always adjust them if you wish to, but if you don't wish to adjust them, you can make the structures bigger. So I can just scale it to let's say 125, for example. Okay, so with that I can put a carbon in the middle. Okay, and then what I'm going to do is I'm going to do the same thing, delta plus, delta minus, which I'm going to copy from here. Okay, so a little bit convenience, just copy them over. Okay, delta plus, delta minus, and then let's say I have a nucleophile, so again I'm going to copy the BR over. Okay, so let's say my nucleophile, if I may simply just use not a BR, of course, let's say NH3, for example. I'm going to just put it as H3N. Okay, yep. Oops. Okay, so okay, so I'm just going to change this H3N subscript. Okay, so this is ammonia as a nucleophile. Okay, so this is lone pair. This is without the charge, so I'm just going to remove the charge. Okay, so it's a rear attack. Yeah, so when I draw the rear attack, I need to make sure the nucleophile is near the rear, and then curly arrows, and then of course curly arrows like this. Yeah, so again I'm going to change them to an angled arrowhead. Oops, sorry. So angled arrowhead. Okay, so you notice that whenever we change it to angled arrowhead, we need to really adjust it. If not, it will look quite ugly. Okay, and then this is the angled arrowhead. Okay, we need to adjust, and then we need to adjust this downwards a little bit. If not, it will look a little ugly. Okay, so the angled arrowhead, we can just make it a little bit more visible. Okay, and then after that, normally in H2 we will draw the transition states. Okay, so the transition state symbols is here, and of course the square is here, so I can just put it in somewhere first. Okay, now some students might not be very clear, or some of us might not be very clear how to draw the transition states. Actually, it can be done quite easily. All we need to do is just to copy this structure over here, and then use the eraser to erase whatever we don't need. Okay, anything partial bond breaking, we'll just put the dotted lines, just put it over here, and then partial bond formation again, I'm just going to put it here. Okay, I'm just going to, you notice that there's a warning sign, right? Because carbon can't have 4 bonds, so I'm just going to remove the interprets chemically and do not display the warning. Okay, and then I'm just going to click the NH3 here. You notice that automatically it will change to NH2. So again, I need to remove the warning again, because if not, later on they will say that whatever I type is incorrect. Okay, so I'm not going to interpret chemically. Okay, not to display the warning. Okay, and this structure looks a bit ugly, so I need to do some adjustment. You notice that when I try to adjust, it goes back to the 100%. Correct? Yeah, so that's not the way to adjust. One way to adjust is just to click this and then put right arrow hit, and then just shift this upwards a little bit. Yeah, so you can use your keyboard to do the adjustment for use to show the pentavalent transition state if you wish to. If not, you can simply just click on this and then manually use your mouse to adjust. Okay, so that will be perfect. Just manually use your mouse to adjust. Okay, and make sure you elongate the bond a little bit. Okay, elongate, and then you elongate this particular group to the left. Okay, and then what I'm going to do now is I'm just going to shift this a little bit to the left, shift this, and then I'm going to shift this. Okay, so that it looks a little better. Okay, and then remember that for SN2, right, the structures will, I mean the stereochemistry will turn inside out, or there's an inversion. Yeah, so normally students or even question setters, right, will redraw the final product. Yeah, that actually takes too much time, so I'm just going to show you a quick way where we can do inversion. But the quick way is to use the help of the software. Okay, so just watch how I'm going to do it. Okay, so I'm just going to copy this over below. Okay, again, I'm going to use an eraser to erase the features. Okay, so I'm just going to copy this again. Okay, I'm just going to go to objects, and then I'm going to flip horizontally. You notice that once I flip horizontally, I get the necessary inversion, and then I'm just going to click the text box, and then I'm just going to click this Control C, copy, and just copy this over. Okay, and this is the final structure I'm getting, which is truly an inversion, stereochemical inversion, but I need to put a plus charge here, because this is a formal charged. Okay, so you notice that once I put a formal charge, the end warning sign is gone. Okay, yeah, so that is how SN2 can be drawn, and how you can draw it in a slightly more effective manner. Of course, nothing is stopping us from simply just inverting the whole thing. I mean, if you wish to do that, you can. But it's just that I thought that sometimes if you are able to find out new ways to draw it, or a more efficient way to draw it, why not just do it? And then if you wish to draw the final step of the deprotonation, you could. Okay, so I'm just going to click on the end. I'm going to draw out, I'm just going to draw out the bonds. Maybe not to a, okay, so this is a H. Okay, so the warning sign is because they do not really understand what this N is. Okay, I'm just going to draw the N in. Okay, and then yep, just going to draw in the N. Okay, so these are the H's, H. Okay, so I'm going to put a plus sign near the N. I'm just going to adjust the size again because it's a bit big, so change it to 85. Okay, then I'm just going to continue the deprotonation step. Okay, so the deprotonation step, we can use back ammonia, okay, because it's the base that is present. Okay, so we're going to form ammonium over here. Okay, so just going to write it as a normal ammonia, so NH3. So it looks neater. Just going to shift this over. Okay, so you can do a lot of shifting. I think you should when we are drawing. Okay, then I'm going to draw the arrows. and then of course another arrowhead coming down to neutralize the charge at the nitrogen. Yeah, you have to do a lot of adjustments. I'm sorry, but you have to do a lot of adjustment because it's not so easy and straightforward to draw sometimes, because after all, the program is trying to help us. Okay, so I will have to do a lot of adjustment to ensure that my structures looks neat. Okay, even for our case here, I need to make it looks more obvious that this is the bond. Okay, so if you notice that now the bonds is not exactly the arrows does not really flow from the bond, right? So I need to elongate this a little bit to make it a little bit unambiguous. Okay, I need to shift the arrowhead back a little bit. Okay, so that is what we can do in our ChemDraw drawing. Yeah, so it does help if you can practice it more often by drawing in, by trying to find out things to draw, so that it helps you to use ChemDraw more efficiently. Of course, there are a lot of other features in ChemDraw which I didn't go into detail. So for example, there are things like there are amino acids here, bicyclics, aromatics structures. There are even clipwares to show you the round bottom flask, even conformers, all this. Yeah, so for those of us doing H3, we can even draw in the conformers, but you shouldn't be using this as it is, because sometimes there is a need for you to do some adjustment so that the structures looks nice. Okay, so I hope this particular introduction, the very brief introduction on using ChemDraw, does help you to maybe find a voice as a platform for you to find a voice of your own in order to start exploring how to use the software more effectively.